Hey everyone, how's everyone doing? All right, we can go ahead and get started. Just want to make sure we start on time. My name is Amy, and I'm a systems software engineer at VMware via the Heptio acquisition.
And my name is Chen Eryn Muetzel. I'm a director of product management at VMware, and I also came through the Heptio acquisition. So today we're going to be talking about namespaces and how to make the best use of namespaces to get the best use out of your Kubernetes clusters. There's not really any consensus today on how to use namespaces. And this can lead to vulnerable applications, and it can lead to some really inefficient use of cluster resources. As the number of teams and clusters and namespaces grows, this can become a really big problem, and it's really difficult to maintain any kind of coherence across your organization. So today, we're going to start with some examples from some organizations and how they use namespaces. We're going to talk about some policies that you can think through and where you should apply those, whether it's at the cluster level or the namespace level. And then finally, we're going to talk through some concepts that you can consider as your organization scales.
Awesome, let's get started. So the title of our talk is Sharing is Caring, your Kubernetes cluster, namespaces, and you. Hopefully you like our Care Bears. So what exactly is a namespace? According to the official Kubernetes documentation, Kubernetes supports multiple virtual clusters backed by the same physical cluster. These virtual clusters are called namespaces. So let's go ahead and break down this definition. Physical cluster. That's definitely a very tangible idea, right? So clusters come with a lot of baggage. You can upgrade and downgrade the kubelet control plane and worker nodes that back up the cluster, and there's fancy ways you can deploy a cluster, you can provision nodes for that cluster. There's a whole thing. A cluster has a whole lifecycle that you can manage. In fact, there's a SIG group that I currently work on internally that targets that upstream team. So just trust me when I say that cluster lifecycle management is pretty hard. So virtual cluster. Namespaces don't exactly need to concern themselves with these details, and namespaces are a great way to logically split up your cluster. Now, why exactly would you want to split up your cluster? More practically, you organize your workloads and group them together. You don't actually need to conflate your workload groupings with the physical cluster. So for instance, let's say you're working on an e-commerce website and you wanted to isolate your shopping cart microservice from your customer analytics microservice. You should be able to do that via namespaces rather than going through the whole process of creating two entirely separate clusters. So when I originally tweeted that Aaron and I were going to present this talk, Nick Young, who at the time worked at Atlassian, responded with this tweet. So he actually now works at VMware. And I thought it was pretty funny and spectacular. So he said, "Remind me to tell you a funny story sometime about the time we accidentally created 80,000 namespaces." So what actually happened was they had a production cluster that was constantly deleting and creating namespaces, and they made a change that caused cascading deletions to fail. So the reason the deletions failed was because they added a non-core resource through the aggregated API server, and this is a known Kubernetes issue based off of some Kubernetes versions that causes garbage collection to fail. And they ended up needing to clean up an etcd database that hit its 2.1 gigabyte limit. So I thought it was just a pretty funny example we can take away from. So Aaron, can you go ahead and break down how some organizations use namespaces?
Sure. So yeah, there's really two common ways that organizations tend to map their people structure to their infrastructure. So the first one is one team per cluster. So in this case, the cluster is likely to be potentially provisioned and managed by the development team that's using it. There may or may not be a central operations team, and this can start to look like shadow IT. And it's very common for development environments. So what are some of the pros and cons of this model? One pro is really the simplicity in terms of the self-service of infrastructure. So the teams that are using the clusters are creating the clusters in the environment that's best for that given application. The other pro about this is you really don't have to worry as much about security risks. So when you have one team and one application per cluster, you don't have to necessarily worry about different teams stepping on each other's toes within a given cluster. In terms of the downsides of this approach, one team per cluster, is really that it can be very inefficient. So it's really difficult to get the best utilization out of your clusters. when you have a small team basically spinning up resources. It also becomes really difficult to maintain coherence, especially as the number of clusters grows. So you can think about, like managing policy across clusters. It becomes very difficult when you have all these teams creating their own clusters. So we'll talk a little bit about more about that later. And then as organizations grow, you'll be more likely to see something that looks like this scenario. So this is where you basically have multiple teams sharing clusters and thus creating namespaces. This doesn't necessarily mean you have these like massive clusters and you have everybody sharing a dev and prod cluster just like that's literally on the slide. But you could still have many clusters across your organization. So why would you want to share your cluster across teams? The first is really a separation of concerns. So you can have a central operator team that's really focused on managing the lifecycle clusters, the policies against the clusters. And then the development team can really live in the land of the namespace. And so it provides them a lot more freedom where they don't necessarily need to worry as much about the underlying infrastructure. Another benefit of this, just like was a con of the previous approach, the pro here, is the cost effectiveness. So as you have teams sharing clusters, it's much easier to get much higher utilization out of those clusters and thus save costs. And then finally, in terms of speed. So if you're a development team, you're getting started on a new application, you want to get access to resources as quickly as possible. So far, the way that development teams have done that is basically just by go on GKE and create their own cluster, right? But in this model, you can also do that, where you have a shared set of infrastructure that development teams can access, provides them a way to move much more quickly. But there's definitely some downsides with the approach. The biggest one being that it's really difficult to make sure that you have the right security posture in your namespaces so that teams don't run into each other and applications create issues in other applications and other namespaces. And then on the flip side, like if you actually do have these controls set, it then becomes very difficult for development teams to have the right level of self-service and speed to move quickly. So for the rest of this presentation, we're going to be talking mostly about this use case 2, and we're going to walk through how you can think about utilizing namespaces and applying policies to these clusters.
Thanks, Eryn. Oh, sorry. Thanks, Eryn. So sharing clusters can definitely get pretty complicated pretty quickly. And let's revisit why we wanted to share clusters by creating namespaces on the shared physical cluster in the first place. Remember again that namespaces allow us to abstract away the workloads from the physical cluster so that the developer doesn't need to worry about the cluster lifecycle. And in order to split up the cluster to draw boundaries, there's some characteristics from a physical cluster that we need to duplicate in order to do this. So for instance, we need to be able to control who is able to use each virtual cluster. So this includes like what permissions people have in each virtual cluster. And we also need to be able to freely change the membership of these permissions for each virtual cluster. So this is under the topic of RBAC. Another characteristic is that we need to be able to limit the amount of physical resources the physical cluster is able to use. So this is under the topic of resource control. And finally, we need to be able to control the kind of traffic that comes in and out of your cluster, and also the kind of permissions that your workloads have running. So this is a pretty broad third topic, which is application security. So because you are sharing the same physical resource and network, your namespace exists in a very low trust environment. So these boundaries are definitely very necessary for an acceptable degree of isolation. And these boundaries, again, are achieved through Kubernetes policy objects, which we'll go into more detail in a second. So before we go into more detail about policies and things like that, we figured why not give some examples of how some of our actual customers are using namespaces today. So these are actual examples that we've anonymized from some Fortune 500 company through like talking to our actual customers. So it's pretty awesome. So the first example is creating namespaces per team. So in this example, one customer has, like, let's say 2 namespaces per team. They have some Kubernetes YAML and a GitHub repository and don't really manipulate their namespaces particularly often. And they also offer admin rights for that entire namespace. In our second example, this company created namespaces per team, per environment. So for instance, an example namespace would be like namespace 1-team1-EKS-dev. So they've actually built an API to automate creating these namespaces. And they also have a templatized pod security policies, network policies, along with other Kubernetes policies. So for this example, though, their developers don't actually have a concrete way to create new namespaces. For a third example, which is a more mixed namespace per team example, some of their teams have, like each namespace can have many applications. Some teams have a separate namespace per application. They use Git operations on namespace definitions, and they also collect information on who administrative contacts are, quota sizes, and they collect this all in a GitHub repository. On top of that, they have an application that goes out and discovers repositories and collates definitions, and they compile it all into a Helm chart, which is pushed out by continuous delivery to their clusters. So this process sets up their namespaces, RBAC policies, quotas, default limits, and requests. And for a final example, this company, they created a namespace per application or category of application. So their Prometheus and Elasticsearch instances were each in their own namespaces, and all of their namespaces were created by the platform operator. They weren't yet at a stage in their company where individual developer teams were able to have their own namespaces, though.
OK, so what are some of the common characteristics between all of these examples that Amy was sharing? These are really 3 examples for how you might structure your organization against namespaces, and I'll talk through some of the pros and cons of each of them. So the first one is basically a namespace per team. The benefit of this approach is it really provides self-management and autonomy by delegating certain responsibilities to the team that's developing against the namespace. In terms of cons, there's not too many. This is actually like a pretty sane approach. The second major way to structure your clusters is by creating one namespace per application. This actually starts to look just a lot like namespace per team. The difference is by specifying the application as the unit, you can create more refinement in terms of the policies that you apply to a given namespace that are aligned with the specific application needs. And then the third is namespace for environment. So this is more common when you look at smaller teams. And it's essentially a way to get more use out of a smaller set, fewer number of clusters. So basically, each namespace is logically discrete, and the development teams can work within this basically isolated development namespace. The benefit of this as well is that the naming of software components can be maintained without collision across these different environments. There are some cons with this model. So a lot of the policies that we'll talk through for namespaces in this case, should really be set at the cluster level. So it's really difficult to achieve the right security posture by setting these kinds of policies in the namespace level. Also, if you do follow this model, it's really still best to create basically a development namespace and a test namespace, et cetera, by application. So instead of having one development namespace, you'd have like a project A development namespace, a project B development namespace, et cetera. OK, so how do we actually start thinking about how to set the right controls at either the cluster level or the namespace level? So as mentioned in the previous discussion of creating a namespace per environment, there are certain controls that are much better set at the cluster level versus the namespace level. So in a shared cluster environment, the cluster is really kind of the land of the operator, right? So some of the policies that the operator is going to want to set in this case are things like cluster access. Who's allowed to do what in the cluster. And you really only want to think about providing cluster access to somebody who needs access to the entire cluster, or somebody who needs more like administrative controls over the cluster. The second is infrastructure security. So this is, really defining like what the boundaries of the cluster itself need to look like. An example is pod security policies, right? So you can set basically the whether clusters are allowed to access privileged pods. Cluster quota, basically how big can the cluster be, right? So setting some definitions around that. That's usually done at the underlying infrastructure level. And then finally, cluster configuration. So should all my clusters be HA? Should they always have Prometheus installed? These are some of the things that you want to think about at the cluster level. So then moving on to the namespace. So again, in a shared cluster environment, namespace is really the land of the application or the development team. So again, here thinking about namespace access via RBAC. So what can developers do within this namespace? Application security is similar, which is basically based on the needs of the application. What are some of the policies that you should be thinking about for the namespace? And Amy's going to go into that in a lot greater depth. And namespace quota as well. So how much resources should development teams be able to use so that they don't step on each other's toes? And Amy's going to spend a lot more time on that as well. Finally, namespace configuration. So are there certain characteristics of namespaces that you want to enforce across your clusters? An example is labels, right? So I want to make sure that namespaces in this cluster always have labels applied to these resources.
Awesome. So let's go ahead and tie the topics Eryn just covered with more specific recommendations. So before I start, I just want to say we're not here to be prescriptive or offer prescriptive recommendations. These are more just like things you can think about and apply them to what works for your organization. So how do you configure your namespaces to meet your security and compliance requirements? These are a set of key policy types that you should consider for your namespaces. So under the topic of cluster and namespace access, the main thing you should be thinking about is RBAC. So you can go ahead and enable user and workload access to either the cluster through cluster role bindings or to namespaces through regular role bindings. So access control is definitely the highest priority policy that you need to configure from the start. So common general roles include admin, edit, and view. The admin role, these roles are all pretty self-explanatory, but I'll keep on going to more detail. So the admin role, it allows read and write access to most resources in the namespace, including the ability to create roles and role bindings within the namespace. It does not, however, allow you to write access to resource quota or to the namespace itself. So you should probably use the admin role relatively sparingly, and you should only use it for the applicator, operator, or DevOps type of persona, because they are responsible for providing access and maintaining your security controls. But like most organizations end up giving this role to everyone, so maybe it's something you should pay more attention to and be careful of. The second role is read and write permissions. This allows access to most objects in a namespace, and it doesn't allow viewing or modifying roles or role bindings. And finally, for read-only permissions, it allows access to see most objects in a namespace, and it does not allow viewing roles or role bindings. It also does not allow viewing secrets. Under the topic of infrastructure in application security, there's a few different roles that you can, a few different policies that you can think about, and the three are pod security policies, network policies, and image policies. For pod security policies, Kubernetes by default allows anything capable of creating a pod to run a fairly privileged container that can compromise a system, which is not good, obviously. So what exactly is a pod security policy? It is a Kubernetes API object that declaratively defines what users and service accounts are allowed to create within their clusters. So this protects clusters from privileged pods by ensuring the requester is allowed to create the pod as configured. The policies are enabled by an admission controller, the kube controller manager modifications, as well as RBAC additions. For more details about this, though, you should definitely check out the Kubernetes documentation. It's definitely adequate and more detailed than we can go into for this 30-minute talk. So the main thing I wanted to cover for pod security policies are these two main concepts, which is the first concept is defining a default policy, which provides restrictive access. So this ensures that your pods can't be created with privileged settings, such as using the host network. And you should absolutely start by creating this restrictive policy that will act as a default for you to fall back onto. The second is creating the concepts of an elevated permissive policy. So what this allows is for privileged settings to be used for certain pods. So for instance, you can probably assign this pod security policy for things created in the kube system namespace. So while restrictive access is like enough for most pod creations, a permissive policy is needed for pods that require elevated access. So for instance, again, in the kube proxy example, it needs the host network to be enabled. On the topic of network policies, they are used to configure how groups of pods are allowed to communicate with each other and with other network points, which is, again, pretty self-explanatory, network policies. So in other words, it creates firewalls between pods running in a Kubernetes cluster. So there's three general network policy strategies. The first is default deny. So for this, all traffic will be dropped unless you set a policy to allow your traffic through. For the second, you can allow traffic through based on like general characteristics. So for instance, allow all traffic to an application from namespace X, or allow traffic from external clients. So these are pretty broad characteristics. And finally, another strategy is allowing traffic based on labels. So for instance, let's say you assign the label to database service, and then you assign another label to application. You can create a rule that says everything in this application can talk to anything with this specific database label. And the third one is pretty short and sweet. So for image policies, it just allows you to specify certain registries you can pull your images from. So obviously, if you pull your images from an untrusted registry, that can cause bad things within your production cluster. Under the topic of cluster and namespace configuration, you can mostly focus on label policies. So you can create certain policies to require specific resources to have a label. What labels allow you to do is to be able to filter resources, understand your resource by some specific attribute, or identify resources for your policy application. So for instance, here are some examples. You can define things like all clusters must have labels X, Y, and Z. Or all Kubernetes objects must have a owner label. And finally, you can say something like, I want all related service for an application to have the same label. And this is on the topic of cluster size and namespace quota. So remember, the point of all these policies are to divide up physical clusters into namespaces. In doing so, operators need to be able to divide and limit the resources each namespace is allowed to use. So this ensures that each team can get their fair share of resources. They also need a degree of security to protect the resources from the physical cluster from being depleted by a misconfigured workload. So for instance, a misconfigured job can cause a cluster to crash by causing a string of job creations before each job is able to successfully terminate and release the resources. So you definitely want some level of constraint there to make sure that your cluster is not completely just like depleted of all its resources. So the Kubernetes object we can use to divide up the physical cluster's resources is resource quota. So this provides constraints that limit aggregate resource consumption per namespace. It can limit the quantity of your objects that can be created in a namespace by type, as well as the total amount of compute resources that may be consumed by resources in that project. So how exactly do you use resource quota? So what you should do is have your administrator create a resource quota per namespace. Users can create resources such as pods and services in the namespace, and then the quota system will track usage to ensure that it does not exceed hard resource limits defined. The different types of quotas are CPU limits, CPU requests, memory limits and requests, object and total object count, storage requests. These are all things that you can definitely check out in more detail in the Kubernetes documentation. So putting this all together, examples of policies that can be created using namespaces and quotas are in a cluster with a capacity of 64 gigabytes of RAM and 32 cores, let team A use 20 gigabytes and 10 cores, and then let team B use 40 gigabytes and 20 cores, and hold 4 gigabytes and 2 cores in reserve for future allocation. So I talked a lot in detail about policies, which again is something that you should go into more detail about in the Kubernetes documentation. But how exactly do you enforce individual policies across clusters? And that's where admission controllers come in. Admission controllers, what they do is they intercept requests to the Kubernetes API server after the request is authenticated and authorized, as you can see in this very broad photo. There's two main kinds of admission controllers. The first is mutating. So what this allows you to do is change Kubernetes objects before they're persisted to etcd as they're coming in. So for instance, you can say something like, change pods with X characteristics to always have the label app::demo. The second kind of admission controller is validating admission controllers. So what they do is they reject and accept Kubernetes objects. So remember how we were talking about pod security policies? They actually need admission controllers to be enabled to be able to use pod security policies. So a related example is you can say something like deployments that do not meet this specific pod security policy are rejected from your cluster.
OK, so now that we've reviewed some of those key policies that you want to apply to the cluster or namespace level, let's discuss a little bit about how the needs of your organization are going to change as you grow. So starting with a small team, this team is likely working on, say, 5 to 10 microservices. They're very likely to just deploy all of the services into the default namespace. Then you're moving to a rapidly growing or medium-sized team. Here you're likely to have 10 or more microservices. You're starting to split a team into smaller teams. And while everyone might know how the complete system works, it's becoming harder and harder to coordinate. So in this case, trying to spin up the entire stack on your development machine is going to be more and more difficult. And it's necessary at this point to use multiple clusters or multiple namespaces. And then moving to a large company, basically not everyone knows who everyone else is. Teams are working on features that other teams don't even know about. In this case, you definitely want to have multiple clusters and multiple namespaces. And then finally, moving to the enterprise, you have groups that don't even know that other groups exist. In this case, you're going to be much more likely to have many, many clusters and many, many namespaces. So as you move to this enterprise scale, things can get super complicated very quickly. So oftentimes what you end up having happen is that individual development teams go off and create their own clusters, right? So everybody's seen this. It can get really challenging, and it can get really out of control quickly. And there's a few challenges with this, right? So first is operators don't necessarily have the control that they need. So they don't have the control over policies in terms of what these clusters look like. And they don't have control to ensure that resources are being used efficiently. The second major problem is CIOs and IT managers. They don't have visibility into the system, right? So they can't actually say whether compliance needs are being met. They can't say whether they're using their resources and money effectively. So to close out this talk, we're going to present a few ideas for how to think about structuring your organization against your infrastructure as your organization grows. And at VMware, we're doing a lot of work in this area. I think Joe Beda has a really great analogy here that he's been using, which is basically that Kubernetes allowed us to move beyond thinking about individual nodes, right? But now we actually need to move beyond thinking about individual clusters and treat our entire resources as a fleet of resources. But when we scale, there's some concerns that we need to address. So in large organizations, there's usually two primary personas. You have developers on the one hand and operators on the other hand. Developers, obviously, are responsible for developing applications. Operators are responsible for maintaining the security posture, ensuring that resources are being used efficiently. And these two teams really have some competing priorities. So developers want self-service. They want to move as quickly as possible. Operators want control, and they want to ensure that they have control over that environment. And this balance between these two groups is really difficult to achieve. And in addition to that, a lot of times the interaction between these two groups is through tickets. So there's basically two goals that we're trying to solve. One is provide development teams self-service access to infrastructure that's not ticket-driven. And second, provide operators the control they need over things like security, compliance, and resource usage. So here's one model that we're thinking about, that we're looking at VMware for how to do this. So the first step is really to create groupings of clusters. So this is really to set consistency. Once you start growing to a very large number of clusters, create groupings, and then you can apply a lot of the cluster level policies that we talked about earlier. The second step then is to enable sharing of these clusters through basically groupings of namespaces. So we do this by basically creating these flexible groupings across clusters. And these groupings you can think of as using them for distinct development projects, where you want to give a common set of users access to the namespaces across clusters, and you want to set a common set of namespace policies across these namespaces which live across clusters. And one way that these groupings can be achieved is through labels. So the truth is there's really not one true hierarchy. So based on the needs of your organization, these groupings may look a little bit different. But something that we're trying to avoid is creating a very strict hierarchy that tends to be pretty common in this industry.
So implementation-wise, though, what does scale actually mean in terms of managing your namespaces in relation to your organization and workloads? So what it actually boils down to is consistency in managing your Kubernetes policy objects. We already talked about how to enforce individual policies with admission controllers. We also need something that manages consistency in interaction between policies. So for instance, you need to be able to consistently make decisions like, can pods in cluster 1 namespace A have privileged pod security policies? You also need to be able to move quickly and change quickly as well. And you also need to be able to enforce these decisions across clusters without needing to manually trace or edit some massive decision tree. So Open Policy Agent's Kubernetes plugin is one way to make policy changes on a cluster without writing a bunch of custom logic, and it's OPA for short. So OPA is a CNCF-hosted sandbox project. It's a general purpose policy engine, and it can be quickly used across the stack. So why do we recommend using a policy engine? Policy-enabled services allow policies to be specified declaratively and updated at any time without recompiling or deploying your applications. Policies are also enforced automatically, so this is super valuable when decisions need to be made very quickly. They also make deployments more adaptable to changing business requirements and improve the ability to discover violations and conflicts. They also increase the consistency of policy compliance and mitigate the risk of human error. So, the point of this entire talk is that speed in software development is on the basis of competition. Organizations need their developers to be able to move as quickly as possible by having access to infrastructure on demand. But on the other hand, operators are balancing this battle where they need to be able to gatekeep the infrastructure to ensure that security and compliance needs are met. So what we hope that you got from this talk is that you can leave with the knowledge to model your organization against your Kubernetes infrastructure based on the size, stage, and specific needs of your organization. Thank you so much for coming to Eryn and I's talk.
Thank you.
We hope you had a great time. Thank you.